Slide 1. Today we thoroughly analyze Rapidus's true aim, the main keep for Japan's semiconductor revival RCS concept, and the supply chain winners. Rapidus, a national project aiming for mass production of 2-nanometer generation. Logic Semiconductors in Chitose, Hokkaido in 2027. Many media outlets focus on the miniaturization process using EUV, the so-called front end. However, investors, please listen. Analyzing from the perspectives of technical difficulty, source of added value, and opportunities for Japanese companies, Rapidus's true strategic stronghold, or main keep, lies elsewhere. That is the back end. Rapidus has opened RCS Rapidus chiplet solutions within the Seiko, Epson Chitose office, and is advocating the RUM strategy to integrate front-end and back-end. Why is the back-end the main keep? And how do Japanese companies like Resonac and Dai Nippon Printing DNP hold the key? I will unravel this with dense original analysis, including the shadow of the Dutch giant Besi and the strategy of the opposing Japan alliance. Slide 2. Why chiplets? The limit of Moore's law. First, let's understand the background of why chiplets are necessary now. Moore's law, which has dominated the semiconductor industry for many years by shrinking and packing. Transistors faces economic limits at the 2-nanometer generation, attempting to make a huge single chip. Monolithic lowers yield and causes manufacturing costs to skyrocket exponentially. The solution that emerged is chiplets. This is a technology that splits large-scale circuits into small dies per function, manufactures each with the optimal process, and then reintegrates them on a package. RCS, Rapidus's core base, is the world's most advanced experimental site and mass production factory to realize this paradigm shift. Slide 3. Bottleneck 1. The wall of hybrid bonding. However, chiplet integration has 3 huge walls that challenge the limits of physical laws. The first wall is connection density. When the spacing pitch between terminals connecting chips drops below 10 microns, conventional solder bumps cause shorts. Solving this is hybrid bonding. It is the ultimate technology that directly bonds copper and insulator at the atomic level without using solder. This requires technology to flatten the surface in nanometers and precision to align with sub-micron error. Slide 4. Strategic choice Besi versus Toray Engineering. In this field of hybrid bonding equipment, the Dutch company Besi holds the majority of the global market share. Global foundries like TSMC use Besi's equipment as standard. This is the market reality. However, Rapidus made a strategic choice here. They dared to partner with Japan's Toray Engineering. Why? The answer is black boxing. If you use global standard equipment, the technology becomes commoditized and leadership is taken by foreign players again. Rapidus aims to build a domestic manufacturing line that other countries cannot imitate by co-developing with Toray, which possesses world-class alignment accuracy, thereby eliminating geopolitical risks. This is the true essence of Rapidus aiming for technological independence. Slide 5. Bottleneck 2. Glass substrate revolution. The second wall is the substrate. Current mainstream silicon interposers are expensive and limited in size scaling. So, the game-changer Rapidus is aiming for is glass substrates. Glass is easier to scale up than silicon and is an ideal material with low electrical signal loss. Leading the world in this field is Dai Nippon Printing DNP. DNP has established technology to open fine through holes, TGV in glass, and aims for mass production from 2027 to 2028. This is completely synchronized with Rapidus's schedule and will be the biggest weapon to counter TSMC's CoWoS. Slide 6. Manipulating light Ushio's exposure technology. However, glass substrates have an exposure challenge. Conventional equipment cannot handle drawing semiconductor-level fine circuits on large glass panels, exceeding 50 centimeters square. Enter Ushio. Ushio holds an overwhelming share in projection exposure equipment for large panels and is developing digital lithography technology in partnership with Applied Materials. Being able to draw circuits on the new canvas of glass substrates is only possible thanks to Ushio's light technology. Slide 7. Bottleneck 3. Chemistry of heat and reliability. The third wall is heat and reliability. Stacking 2-nanometer chips at high density generates tremendous heat. Also, thermal stress caused by bonding. Different materials can destroy the package. Supporting this are the chemical materials of Resonac, NCF film that fills the gaps between chips and protects connections, and TIM heat dissipation sheets that efficiently escape heat generated from chips. The biggest reason why the back end is the main keep is that this is the world of chemistry, not physics. No one can surpass Japanese companies in the integration of chemical materials. Slide 8. Lessons from history. Why win this time? Here, let me answer a question investors might have. Will it fail like the past Japanese semiconductor project, Solite? In conclusion, the structure is completely different. Solite was a hodgepodge of competing domestic manufacturers. They hid technologies from each other, and the exit strategy was vague. However, the relationship between LSTC and Rapidus this time is vertically integrated. Only Rapidus uses the technology. There is no conflict of interest. Furthermore, material and equipment manufacturers are participating not as subcontractors, but as co-development partners. If Rapidus wins, everyone wins. This clear alignment of interest is the winning formula this time. Slide 9. The future flow drawn by RUM strategy. Imagine the future manufacturing flow realized by Rapidus's RUM strategy. Circuits are drawn on DNP's glass substrates with Ushio's equipment. There, chips polished by Ibera's CMP are mounted by Toray Engineering's bonder. The gaps are sealed with Resonax NCF, completing a robust package. This entire flow is completed within the Japanese supply chain. RCS will serve as the strongest showcase to demonstrate the power of Japan's material and equipment industries to the world. Slide 10. Conclusion. By the rulers of the back end. In conclusion, when you hear the news of Rapidus's 2-nanometer mass production, focusing only on miniaturization is missing the point. True added value is shifting to the back end. There are business opportunities for Japanese companies capable of solving each technical bottleneck. Resonac, Dai Nippon Printing, Toray Engineering, Ushio, Ibara Corporation. Riding the ship called Rapidus, they are trying to grasp the navel of the global semiconductor industry. And they might be the true winners of the next era.